Okay, let's apply everything that we have learned so far, or talked to so far, to this problem here. It's an electric power transformer manufacturer predicts its demand over the next 4 months to be 1, 3, 2, and 4. Let's draw a little line. Timeline. So we're right here at time 0 and 1, 2, 3, 4. And what is happening? There's going to be a certain amount of production. Well, let's see. Currently has no units in inventory. In order to meet the demand, it has to decide whether to produce all the units at once, just the number of units required each month, or somewhere in between. Let's think about that a moment. So we have a demand. We don't know when in the month that demand's going to come, but let's assume that it comes somewhere near the end. So there's a withdrawal. And let's designate this as D1, the demand in month 1. D2, D3, D4, and the numbers are 1, 3, 2, and 4. Okay. Now, in order to draw the demand, you need to have some supply. So there's going to be some addition. Let's assume that gets added on really in the early part of the month, or at the beginning of the month. We add some units. And the question is, do we add the units? Do we add them all at once? So there's a total demand of 6 and 4 is 10. We can make 10 units right at the beginning, and that's the end of that. Or we can produce them as needed. And I guess that's the question. In order to meet the demand, it has to decide whether to produce all the units at once, just the number of units required each month, or somewhere in between. What makes the problem challenging is there's a holding cost of $500,000. So a holding cost would tend to make you think that you don't want to produce them all at once because you don't want to have units in inventory. But there's also a $3 million setup cost, which means that you don't want to produce very often. So, which means you do want to set up roll at the beginning. So that's the issue. It costs $1 million to manufacture one transformer. There's enough storage space to hold up to 4 units and sufficient production capacity to produce up to 5 units. So you'll be asked, because this is a dynamic programming problem, you'll be asked, what are the stages of this problem? Well, the stages are clearly the months. So we have the months. T equals 1, 2, 3, 4. We have the beginning of the month, the end of the month. We have to decide, make some decisions. That's usually the easier one to identify than the state. The decisions is how much to produce, the production. In month, so let's say instead of in month T, let's say at beginning, at start of month T. Let's designate that by XT. So this will be X1, X2, X3, X4. Now, before we decide how much to produce, we need to know how much is in inventory. So the states are the inventory levels. Inventory at, now we need to know when. So it's at the beginning. But right before the production. And it'll be ST. So we'll have the inventory right at the beginning of that month, and then the inventory right at the beginning of the second month, beginning third month, beginning of fourth month, and I guess this is the beginning of the fifth month. Don't know. Let's deal with the transition. So we are dealing with the inventory of at the beginning of the next month will be the inventory at the beginning of the previous month plus whatever you produced minus whatever you took demand. Now there are different ways of doing this with the index, but this is just one way. And we also have given that S1, which is the inventory at the beginning of the first month, is 0. Now let's deal with the immediate cost. Well, the immediate cost, which we designate as HT, ST, XT, well, it's a combination of the holding cost, the inventory cost, the setup cost, and that depends on whether there's any production at all. So if XT is equal to 0, then it will just be 0.5 ST. But if XT is greater than 0, then we have to pay $3 million plus $1 million for every unit that we produce, and then plus 0.5 ST. Now we have the cumulative cost. From now everything is from the beginning, so let's say from beginning of month T to the end of horizon, and that will designate as FTST. So we have all our, so the cumulative cost beginning of month 3 to the end of month 4, for beginning of month 3 for that month, will be the accumulation from that point on, and we'll deal with that at the Bellman equation. Just let's take a brief break.